students, now we are going to discuss about the basic natures of amines. So let's start with the basic nature, but before starting with it, we need to know that it consists of nitrogen, and every nitrogen consists of one lone pair, that is, it consists of two electrons. Now, because it consists of excess of electron, it would be acting as nucleophile and also it would be acting as a base. Now, let's see further. What we are going to do is, we are going to take the basic nature of amines, and for this, we require one reaction, that is, reaction with aqueous mineral acids. Now, whenever we see this reaction, let's see what happens. We take an amine, to this RNH2, we add an aqueous mineral acid, that is HX. Now, what would happen? N would donate its lone pair towards hydrogen and X would be removed as X minus. So what you are going to get is nothing but RNH2 positive, attached to it is H, and attached to this entire thing is X minus, which can be written down something like RNH3 positive X minus. Now, this alkyl ammonium halide, which is obtained right now, is nothing but a product of the reaction between amines and acid. But what if it dissociates? On dissociation, it would reverse the reaction and giving me back my amines. So now, what we can say into this first step is nothing but amines are basic in nature, and a very important point, amines act as Lewis base because it donates a lone pair, but in the process of donation of lone pair, he is accepting a proton. That means he is acting as a Lorentz-Bronsted base also. Right, students? So remember this point, it is very important. Let's move further. Now, let's start with some examples. Let's take an ethyl amine. To this, we would add HCl. Now, what would happen? The first thing which would happen is nitrogen would donate the electrons towards hydrogen, chlorine would be removed as Cl minus. So what you would get? We would get a compound, that is C2H5NH2 with a positive charge, attached to it is H, and attached to entire thing is Cl. So now, this can be reframed as C2H5NH3 positive, Cl negative. Now, in this entire compound, again, if it dissociates, the reaction would be reversed. And what you would obtain? Again, you would obtain ethylamine. But now, does our product consist of ethyl group? Yes. So it consists of an ethyl group. So now we would write ethyl. Achha, does it consist of NH3? Yes, it consists of an ammonia group. So we would write ammonium. And does it consist of chlorine? Yes, it consists of chlorine. So we would write chloride. So what would be the name of the product? Is it ethyl ammonium chloride? Yes, it is. Let's take the second example for now. Let's take aniline. Now this aniline again is treated with HCl. What you would get? A reversible reaction. And in this reversible reaction, we will get a product, that is benzene ring attached to NH3 positive and Cl negative. Now, does it consist of a phenyl group? Yes, it consists of a phenyl group. Is it having ammonium group? Yes, it is having an ammonium group as well. And lastly, is it having chloride? Yes, it also has chloride. So what would be the name of this compound? It would be phenyl ammonium chloride. Let's take the third example for this, a very tricky one. Now, we again take ethylamine, but to this ethylamine, we add H2SO4. So what you would get? Obviously, we would get a compound, that is C2H5NH3, which would be our first product. But now, we need to remember H2SO4 is a diprotic acid. That means he would give me two hydrogens, right? And because of this, we would take two molecules of ethylamine. So what you would get? We would get C2H5NH3 two times. And to this, SO4 minus 2 would be attached. Now, what exactly is this compound name? It's named as ethyl ammonium sulfate. So this was all about the reaction with mineral acids. Let's talk something when amines are reacted with water. Let's see this. We take an amine, treat it with water. What would happen? Again, nitrogen donates a lone pair towards hydrogen, giving us a compound that is RNH3OH minus. So, what we are getting again? We are getting almost the same compound. But now, what would happen? Upon dissociation, again the reaction would be reversed and then we would get as amines and water. A very important point over here which we need to remember, NH2 is a weak base, OH minus is a strong base. So because of this, the entire equilibrium of the reaction would shift towards the amino side. And because of this, we would say the forward reaction is less preferred, backward reaction is more preferred. Now, again, a very important point. Let's apply law of mass action to this. What we would get because of law of mass action is nothing but K is equal to active concentration of RNH3 positive into OH minus divided by active concentration of RNH2 into active concentration of water. Now, if this same law of mass action formula was rearranged, let's see what happens. We take the water onto the other side. So what do we get? We get K into water molecules or into active concentration of water is equal to RNH3 into active concentration of OH minus divided by active concentration of RNH2. But K into active concentration of water is Kb. Therefore, now what we would say, Kb is equal to RNH3 positive into active concentration of OH minus divided by active concentration of RNH2. Now we all know if the value of Kb goes on increasing, the base becomes stronger. But if the value of pKb goes on increasing, the base becomes weaker. So what we can say, higher the value of Kb, stronger is the base. Lower the value of Kb, stronger is the base. Right? So this would be the last point, a very important point. This was all for this module, students. Meet you in the next module. Till then, thank you.